All right, so we are going to start our project-based learning with a shelf. And what we're going to do with the shelf is we're going to create the shelf, assemble it all together, and then finally run FEA on it and perchance some design study. So what we want to do is we're going to create the shelf, and I would like the top of it to be a foot wide and 4 inches deep. So to start with that, we're starting with the top. We're going to click Sketch because that's what we always start with. Select the top plane, and we have our selection of tools up here. If we select the corner rectangle, that would probably be the easiest in this case. We select that, we click on our origin, and now we can draw this rectangle as large or small as we want. And for right now, it doesn't matter the size because now that we have this, our sketch is undefined down in this bottom right. And usually we don't want that. And see, it's underdefined, because you can just drag this wherever you'd like. Well, we would like it 4 inches deep, 12 inches wide. And to dimension things, you only have to click the Smart Dimension. There are different dimensioning tools here. If Smart Dimension isn't quite smart enough to select the right dimension for you, and we'll probably go over those in a little bit. So now that we have that, our sketch is fully defined, and now we can select Exit. So we're still kind of looking down, and we can rotate by holding down the middle button of our mouse and just dragging it, the scroll wheel button. And to make this into a solid piece, well, we just select Extruded Boss slash Base. I usually just call it the Extrude feature. And let's say I want this 1/2 inch thick, just like that. Um, a setting from when I was messing around with it earlier, there's different settings here. Blind, up to vertex, up to surface, and the rest of these. Usually you select blind. Um, Up to vertex means you just select something and it goes up to that. Same with surface and offset from surface. Up to body, you select a body, but usually you normally just do blind. We have the check mark on that. And now we have this flat piece. Now, I'm envisioning this shelf. Um, it has braces. It's going to have two braces because what it's going to be holding is pretty heavy. Um, and to get these braces at about, oops, sorry, here and here, well, we need to drill those holes. And to drill those holes, essentially, we're going to want to go to Hole Wizard. And now, granted, you can go to Sketch, sketch out some points here, and I'm actually going to do that. It's very helpful to do this. You could always draw the holes with a circle, but usually I use Hole Wizard because there's a lot of options. Um, so we're just going to select Sketch. We're going to go here, and keep in mind that there's also going to be a back piece here that's mounted on the bottom that's also going to be needing holes uh, here. So we have to put our holes on this shelf here accordingly. And what you want to do is create points. And I think that these points are they're very useful, especially when you're using the hole wizard. So you can just select points on this surface and see how they're only on this surface. That's what you'd like. And say you're me and you've rotated out of your original 2D view, and say it's hard for you to understand. Um, you can just go up here, and there's this view orientation button, and you can just select back at the top. Now, we actually rotated. It doesn't really matter too much which side we make these offset to, where the other board goes. But in any case, we select our Smart Dimension tool, And I want these to be 1.75 inches away from each other. And we can also do the same over here. With that being said, they also need to be known how far apart they are. And we actually don't need to know that because we can select on this edge over here and say I want them 2.25 inches away from the corner. Notice how these are still blue and it says undefined. That's okay because what that means is I can move this anywhere like this and I should be able to rotate that. And that is something we do not want. To prevent that from occurring, we can go up in this top area, click on the down arrow of display/delete relations and add a relation. And it can relate to entities essentially. So after you select the 2 points, I want them to be vertical. So now as you can see, these things are always going to be vertical. So I can move it up and down, but I can't rotate it anymore. And that's okay. Now, I'm going to say that the other board is going to be on this back side, the bottom side here. Well, I know that board is also going to be 1/2 inch thick, so I want to make these screw holes accordingly. 1/2 inch thick, let's just go with 1.25 inches. I'll just go 1.5. So, see how these are all black? I can try to drag it, and it doesn't move. Now, these can still go everywhere. See how they're all rotating and they're just doing a lot. What I want to do is I can add relations from here to here. I can make them horizontal. See, but this one can still rotate. So I can also add relation, these two, vertical. So now they're only allowed to move left to right. And so from here, we know how much this dimension is. We can go here to here. We can actually go like this. It has a pop-up, and if we want, we can just select that dimension there, and there we go. So right now, all we've done is made 4 points. We will make two more, or maybe three, for this back side for holes we drill there. But I want to exit, and now that we have these points on our shelf, we need to add the holes. So we select the hole wizard, and I want these to be countersunk screws. There's a lot of different hole types. There's counterbore, countersink, and there's just hole. There's also uh, yeah, the tap. Counterbore, that essentially is where the head of the bolt is a rectangle, like this. When you view it from the side, it's a rectangle. Um, and that means it's just like a full bolt head. You can also countersink screws. You can even just straight holes. And obviously this one is going to be countersink, just because I want to. And 3/8 is going to be a little large. I'm actually going to put 1/4 inch screws in there. And we go over here and we can select positions. Now, you can 3D sketch, not a big deal, or you can select the face that they're on. And I know the face that these holes are going to be on is this top one. So we select that. And remember those points we made earlier? It makes it incredibly easy to just select the points. And our sketch is fully defined because it knows where those holes are. So we go back and we can kind of rotate around it real quick. And we see that these 1/4 inch screws, they're there. And there's a taper here. You can't really see the taper besides from the top view. But there it is. Those are our 4 holes. We hit the check mark, and there are our holes. Perfect. We're going to do the same thing for this back row. And once again, we can just select the sketch, but instead this time I'm going to show how you can do it just on the hole wizard. I find creating a whole nother sketch and adding points is much easier, but it's up to personal preference. So we're going to select the surface, And now I'm just going to put three of them back here. Now, see how it says underdefined? These are defined, but these aren't. I would like this to be 0. Well, 0.25 because the board's going to be half an inch thick. And as you can see, um, this top little bit here, it's not doing too hot. See, it kind of clips outside, and that's not something we want. So I'm going to continue dimensioning these, but we're going to change the size of the bolt or the screw. And notice how I could have made all of these with a relation straight across, but I didn't. And what I'm going to do, select that. I want that to be an inch away. Same with this thing, 1 inch. And this one. This one's interesting because usually you'd want it in the middle. So what I'm actually going to do is I'm going to select this point. Oh, I can't do that. I'm going to add a relation from this, and usually with another point, you'd be able to select the midpoint there, but unfortunately I'm unable. So what you could do is add a center line, and a center line, it means it's going to be dashed. If you look really close, there's little dashes. I'm just going to make this line from here to here. Okay? Not a big deal. Notice how this thing can still move left to right. Now I can add a relation to this, add relation, vertical. And now we have a fully defined sketch along with all of our holes. And like we said before, I would like to change that type of bolt or screw. And all we have to do is go back and we can select a different size. Now, unfortunately, it appears that the lowest standard size is a 1/4 inch. And what we can do with that actually is we can just select a smaller size. And there's different types of fits. Say I just used a size 8. A size 8 isn't, or a size 8. That's just the size. You can order screws from McMaster Carr in any different size, um, but that's not the point. The point is you can select any screw size, and at least for this project, you can. So now that we have that, let's just change the other ones to size 8 as well. And how I did that is you select the feature that they're on, select the feature, right click it. As you can see, you can edit the feature. Well, we just want size 8, check. And there is our entire piece made. Now, our material is not specified. And just to specify a material, we can just go to edit material. And SolidWorks has a lot of different materials built in, has a lot of different other materials built in, and you can make your own custom materials as well. This specific piece, I would like to make it out of plastic per se. And ABS or ABS PC. ABS PC seems a little bit stronger. You can make it out of nylon and all this other different stuff. Uh, Usually most of our parts and on the Baja team are made out of metal. But let's use ABS PC. There's all these different properties on here. Usually you'd like most of them filled out. Compressive and yield strength might hold. They might have a little bit more difficulties later on, but we're going to find out once we finally get to putting it all together. So we're going to click apply, close. As you can see, now our piece is a little bit transparent, and that's okay because, yeah, you just change it right back. So now what we need to do is we need to save our part. So we can hit save, and I already have a folder, full project walkthrough of the shelf, and we're just going to label this top, or shelf top, shelf top. There is a specific naming system that each year kind of has. Pay attention to that as you're naming your parts. I'm just doing shelf top, so it's easy for me to remember. and it's not on the file server. We're going to hit save. Now that we have this, there's a few more parts we need to make, but we're going to leave this open. We can select, once again, up here in the top left, New, Part, hit OK. We have a new part. Now, once again, we can start with a sketch. And last time we selected the top plane, and we can do the same thing, or we can make it easier on ourselves, hit the front plane. Now, this backing of the shelf is what gets mounted to the wall. So once again, we're going to select our corner rectangle. And this is just another, this goes on the back of it. And we can select Smart Dimension. And we want it to be the same width. So we'll go 12 inches. Height, notice how there was, I'm going to make this a rectangular, kind of like a rectangular prism, but two of the sides are the same. So we know that the other one was 4 inches, right? Minus the half an inch of board, or in this case plastic. We select enter, and it will do the math for you. You can do very complicated, I say complicated math, like 3.5 to the power of 2. Say you need that for some reason, and it would do it. But we know it's 3.5. We'll just hit enter, and we'll go from there. We'll hit the check mark. Once again, we'll select exit, and we will extrude it once again. And this time, let's go with the same thickness, 0.5. All right, we have our board, and now we have two sets of holes, or two sets of holes to drill. One is going to be on this face, and the other is going to be on this face. The ones on this face, there's going to be braces here and here at our dimensions. And on this one, there's going to be the holes drilled down. Now, what we can do is we'll go sketch, we'll go here, we'll put down 3 points. We will dimension them. We know this one was an inch away. We know this one was an inch away. And we know this one was a center line. And see, we can add lines, and there's a whole bunch of orientations. This one I want to be specifically vertical, but we'll do it as sketched so we can add our relation later. So we need that midpoint, which is right there. Okay? Select this, add relation, make it vertical, boom. And so this thing can still move up and down, so we need to dimension the length of that, which is 0.25. So that one is all black, which means it's all locked down, and these two are not. So instead of adding dimensions to those, we can add relations, and instead of adding more dimensions, they're all related. And sometimes this is good, and sometimes this is bad. If you'd like to keep all of these in line, no matter what the distance is away, add relations. But if you want to have them different distances, possibly, later in your design, do not. So notice how I, for some reason, exited my sketch. To get back into it, we just right-click the sketch and hit Edit Sketch. Very simple. So this one, I'll just show that it does the same thing. Everything's black, fully defined, we're good. Now, we're going to add a feature. We're going to go to Hole Wizard. There are more options here, but Hole Wizard is the most common one. Hole Wizard, we're already on size 8. We go to Positions, we select our surface, and all we got to do is do that. And notice how it went all the way through. Okay? We're going to change some of those settings. But also notice these are tapered too. You do not want that. So what we're instead going to do is we're going to select Hole. Size 8. And look, instead of having the taper, it just has a hole. And so this is usually how holes are made. You don't have two countersinks with only one technically being used, if that makes sense. So what we're going to do is we're going to select our ink condition to be blind, and I want these to go an inch in. I lied. I want them to go half an inch in. So that's how that works. Hit the check, and boom, right there. And this sketch, it kind of looks a little weird because I have that line in there. And if you don't want that to be showing, you can just select hide on that sketch and it'll be gone. Now it's time to have more. And by more, I mean we're going to create holes in this. And so I'm thinking that since this is the back, we're going to have holes all the way through it. Which means we're not going to have okay, we are not going to have holes all the way through it. Whenever we do the design or the FEA, finite elemental analysis, this entire back, we're going to act like it's glued to the wall. So simply what we're going to do is on this back side, we're going to be creating more um, countersunk screws that go this way, that go into the braces. So sketch. And this time I actually want to create a center rectangle just to show you guys the different tools. We're just going to draw it out like this. See how it reaches both edges or same edges at the same time? That means it's in the middle, but it's not in the middle vertically. So I'm just going to do that. And we're going to select 4 points. 1, 2, 3, 4. We just created 4 more points. Now, if we go back to our other design, we know that these, hold on. Sometimes you have to go into where they're at. Oh, we made them on this one. They are, do I want to make the, okay, we're just going to make it, how I feel. Okay, so we can add more relations, but instead before that, I need to create the center point here and the center point there. So add relation between this one and this one. They're always vertical. Between the center point of the rectangle and that point, add a relation. They're always horizontal. Now, that's if we want the pattern to be in the middle. And I think I will have it in the middle this time. These screws will probably be a little bit closer together. Uh, we're just like that. We'll go 1.5. And how far across they are, let's go 10. So keep in mind that the the board, the braces, they're going to be in the middle of this. Makes sense? These holes are going to define them. So we can just hit check. And our sketch is fully defined. This is where I want the holes. We'll have to exit. We can go back to features, full wizard. And this time we want countersunk screws, positions, select the surface. All we got to do, select those 4 points, hit check, and then we're good. So I'm going to hide that sketch. So as you can see now, these two won't be an issue. At least we will find out if they're an issue, but they shouldn't be. We have our plate here. Now we need to make the bracing. So once again, we're going to save this part. Instead of shelf top, we'll go shelf back, enter, and we need one new piece that we'll just duplicate twice. We're going to make an assembly and do it from there. Well, we're going to make a sketch. So our front plane was used for the back, our top plane was used for the top, and to stay with the same type of coordinate system, you could say, I'm going to select right plane. And I'm going to make these triangular. triangular supports. One, two, three. Now, these supports are going to be fully covering, they're going to go to the ends of the board. Okay, so we know that our top board is 4 inches. We have half an inch being taken up on the bottom by the other board. So that's 3.5. On this one, we have the board that is 3.5 inches tall and not being taken up by another board, so it's another 3.5. So this sketch is fully defined. This is what our brace is going to look like on the side. Exit. On our features, we're going to extrude it, and we know we want it to be half an inch, just like everything else we've made. Now, here comes the slightly tricky part, getting the measurements on here. So, we'll start with the top. I would like to show you the evaluate tool. You'll use this a lot on the Baja team. You go into evaluate, you can select measure. After you select measure, there's different units and just different distances there. Usually you leave it the same unless there's something specific. But what I'd like to do is I would like to select this circle and this right there. So notice how it says center distance is 0.75. So it means from the end, it's going to be 0.75. Okay. And then from, from this circle to this circle, it's 1.75. So that's good. So now hit X, we'll go here. And so this is our top. We can go to features, hole wizard. We want just the hole, positions, select this top one. Now, put 2 holes down. We know that the first hole is 3/4 of an inch away. And we know that this hole is 1.75 inches away from that as well. So how are we going to align these with the center? Well, all we have to do is select that. From the edge, we know it's going to be halfway, 0.25. And so it's not all black yet. So what we're going to do is we're going to add a relation. These two are going to be vertical with each other. Check. They don't move anymore. We can hit good, and there we're good. So this hole goes down half an inch, and I think this should be fine for now. And we will know in the FEA because it'll tell us that whether this hole is down too far or if this starts bending a little too much. So now we need the back side, and we can do the same thing. Shelf back, go over here, evaluate, measure. From the bottom to here is an inch, and from that inch to the other hole is an inch and a half. Exit out, go here. And this time I'll just do the same thing. I won't make an entire other sketch. Let's go straight to the hole wizard, positions, and points. One there, and one there. Remember this was an inch and a half. I believe this was an inch. That looks about right because there should be an inch on the top here. Okay. And now they need to be in the middle. So easy enough. 0.25, enter, add a relation, vertical. Fully defined, as it says in the bottom right. Hit the check mark, and there we go. This piece is now done. Once again, we can change the material. We can just edit material. And I forgot what I selected on the other one, so we can just go ahead and check that. And I will go ABS PC. So, did I do that on the shelf back? I did not. So I go here, edit material, plastics, ABS PC, apply. And it does make it transparent. That's okay. Um, it doesn't technically do anything. You can always change the transparency later. And a little quicker trick is if you right click, these are your favorites. And you can change your favorites in the program itself. You select ABS PC and go from there. So now that we have that, I would like to save this part and then we'll go shelf support. Enter, and there we go. Now it is time to assemble this all together. We're going to hit new. And since we can make assembly from part or assembly, um, it says I'm running low on memory. So what I'm going to do is I'm going to close out um, my current SolidWorks tabs, and we're just going to create an assembly separately. New, assembly, we're going to hit OK, and it pulls up our files. So in your files, you can select, should be able to select all of these. Hit open. In this case, I would like this piece, the backing piece, to be fixed. So if I just select that, put that out there too, and this, we should be good. So I don't want the transparency to be changed. So as you can see here, if you right click on it, you can change transparency. And I want them all to be solid. So what we can do now is this component is fixed. The first component you place is usually fixed. And that'll happen in assembly. So you'll be like, oh, this component's fixed, and you'll try to fix it with a whole bunch of mates. Um, Sometimes you just don't even want to try. So this is fixed. That's fine. To put this all together, though, are mates. You select a mate, and I'd like to put this bottom brace on first. So if I select this hole and this hole, because those two line up, they're spaced apart, but it looks like it's almost centered, and it is. So it's kind of centric to that hole. Okay? So usually your mates are pretty self-explanatory. So if I select this and this, they're concentric. And so what concentric does is it just lines up the middles of the circles. But notice how I can still move it in and out. We don't want that. We know that this face would usually be pressed up against that face. And so coincident, that's what it does. It means they touch. You don't want perpendicular, or you could technically have parallel, but since you have these concentric holes, it works just like this. So you just hit the check mark. And now, if we X out of the mates, it's fully defined. This component is fully defined. Um, oh, it looks like we didn't make the holes right. We can go back and switch that. All right. So what I'm also going to want to do is select mate again. And we'll go at the bottom of that hole, not to that. So if we select the wrong thing, we can just select it over the mate selections, hit delete, go back over. We should be able to select a new one. Okay, sometimes it messes up. So mate, middle of that circle, middle of that circle, go for it. Just drag that up. And you're kind of, when you're doing an assembly, you're putting everything together the way you would in a, in real life. So like that. So you'd line those two holes up, and then you'd bring this entire piece down, just like that. So as you can see, our holes aren't lined up here. And that's a little problem, isn't it? So what we're going to do is we're going to evaluate it real quick with our measure tool, and we know that those holes need to be an inch away from the edge. Okay, so something interesting you can do in SolidWorks and many other programs actually is open part in position, and you can edit a whole bunch of things. So you can edit the part. It says we have to save it first. That's okay. We'll just put shelf assembly. I probably spelled that wrong. Um, what it'll do, it'll allow us to edit the component, and we want these holes to move. Well, lucky for us, we can edit our sketch, and we know this needs to be an inch away, and we know that this needs to be an inch away. Hit the check mark. We can exit sketch, and we can exit editing the component, and now everything's fine. So if you look close, that hole goes all the way through, and that's exactly what we want. And that's why I usually do sketches like that, because they're super easy to change without having to go in anything super deep. And so we need another shelf support, don't we? Because there's another one over here. So we can copy with mates, and usually I don't do this because sometimes it all gets a little bit screwy. So I'll just select a component, Control C, Control V. Let's pop out of thin air, of course, because that's how it works. And we'll go to mate. Once again, we'll go that to this, hit the check mark. And to make it easier on us, we'll go this to this. And that should lock us completely in. We have a fully defined assembly. This is what it looks like. Lots of screws, lots of awesomeness, and we're going to have a weight pushing down on this. And so real quick, I just want to save that. Save them all. Now that we have this. So what exactly happens here? Well, earlier I technically forgot to add a little circle in here, which is where our pressure was going to be applied. But instead, I'm just going to act like a big old foot is stepping on this whenever we evaluate. So that's how you assemble an entire uh, assembly, essentially. So this is against the wall. We're going to act like this is just glued straight to the wall and nothing's going to move or anything like that. I could have put screw holes in here, but I'm not doing that. To start simulating, go to the simulation tab. And we should have materials for all of these so far. We're going to select study, and it's going to open up all this fun stuff. We'll name it um, shelf study. And usually static is what you'll use at the beginning level. There are many different types. So right now I'm working on learning more design and topology. There's a lot of different other simulations. But for this one, let's use static. We'll hit the check mark and we'll go from there. So it appears that this thing has some weird transparency again. But anyways, we're going to first add a fixture. And a fixture, it just affixes something. And as we can see, fixed geometry. It has a little example actually, where like kind of like a bending a beam, one end is supported, the other isn't. So in this case, this beam, this part, and we'll go with this part, is supported. With the check mark. So those green things of awesomeness, arrows and vectors and stuff like that, those tell us that that part doesn't move. And so everything else is fully defined. Um, Here's our external loads advisor. I actually would like to add a force to this. So a force, we can just select on this, and we want a uniform force like this. And we can have English units too. And I'm not sure how much weight I'm going to put on this. But let's say I'm going to step on this thing. Um, and our units are English pound system or IPS, whatever, and pound feet. So essentially, I'm going to want to make, let's just make this 120 because I am fat. And that's pounds per foot. And so we know it's a pound feet. I'm not really sure about the distribution, stuff like that, but it's fine. We'll put the check mark on that. And now there's a lot of different other loads that you can add on, like a torque. You can put um, temperature stuff, and because temperature affects the load on a piece too. There's also connections, and there's like pins, there's bolts, there's edge welds. So if this was technically a metal piece and I welded that, you could technically put that. But real quick, I'm gonna add bolts or I guess pins. I don't know um, which one matters. Um, oh, it looks like it does matter. So countersunk screw and nominal shank diameter. There's a whole bunch of other stuff you can add to this. Um, I'm going to just add a pin. It's easy enough. There's just so much stuff you can do. Um, but in fact, I'm just going to act like I'm not going to add any of those for right now. I want to show you the what everything looks like. So usually you want to create a mesh and you can set your mesh density. You can also get super deep into it. But right now we're just going to mesh density. We'll go about in the middle. That's how it's usually set. We'll hit the check mark. It meshes everything. So as you can see around the holes, it's like, oh, what's going to happen here? And it goes from there. So now that we have all of our forces and fixtures defined, I'm going to select run. What it'll do, it'll solve it. Um, and this depends how fast it depends on your computer. And as you can see, it looks pretty warped. But this is von Mises or Mises stress. You actually want displacement. And so the further we look at the displacement, um, the easier it is to realize that our our scale up here is 2.315 times 10 to the negative 1 millimeters. So that's essentially, it's moving zero point 0.2 of a millimeter. That's how much this spot right there is deflecting, assuming this back surface is fully loaded, and so is that. And it even shows that this is kind of bending a little bit, but it's very not noticeable. And so there's a lot of just different graphs you can put on this. So there's a lot of strain put specifically on this this bolt right there. So that might be something you look into for optimizing later on. So as you can see, there's also a lot of strain here, there, yeah, a lot of everywhere. So interpreting these results is another thing. A lot of times it's sometimes difficult to look at this and be like, oh, what is going on? And I think that's completely normal. Um, but yeah, that's how you basically make a shelf. And it would be more accurate if I added pin supports here or screw supports if I knew actual values of what what the screw was, like different shank nominal diameters and how tight the fit would be or how much torque I torqued them specifically down to. Um, but yeah. And also keep in mind that though this is made of ABS, it's assuming this ABS is completely solid, like cast ABS essentially. This was not made with a 3D printer. I'm fairly certain it probably would hold you, but I think it might deform a little bit more. So yeah, after that, if you'd like, you can just save everything and it will save the statics and stuff with it. So yeah.